Welcome to Walk About the Galaxy, our astronomy podcast, where the
True.
science is universal, the opinions are personal, and the sponsor is whimsical. We are Strange, Charm, and Top, the Astroquarks, also known as Josh Caldwell,
Addie Dove?
And Jim Cooney.
coming to you from the Walkabout Studios in Central Florida.
True.
Our stumpers today are energetic.
Okay.
Just like us.
Jim,
yeah.
I want to say Furbs or Gerbs?
Furbies.
Furbies?
That's what we're
Or
calling them.
Furbies
Furbies.
or Gerbs, but I'll say fast radio bursts or gamma ray bursts. I just have a feeling that astrophysicists are having all these bursty things. And
But bursts are fun, right?
yeah. And there's always like, oh, that's the magnetic star, but this is the really magnetic star. Well, that's the really bursty thing. This is the very bursty
Super
thing.
burst. Yeah.
Fast.
Well, the fast radio bursts have been all over the news recently. We've done things, so you got to go with that. I mean, it's very sexy. It's very exciting.
And you can call them Furbies. Do
And
you
you
not
call 'em
remember
Furbies.
Furbies?
Isn't that some kind of a thing where
They
people
were
like
stuffed animal things.
ride
Is that a-
other people and stuff like
They were
that?
stuffed
Furbies?
animal things when I was younger.
Is
Oh.
that on the Muppets or something?
I don't know.
They're... No.
Or was it one of those, what were those toys,
Yes.
these stuffed things that were like $5? What were those called?
Beanie Babies?
Beanie Babies. Thank you. Very good. Very good pickup
Wow.
on that.
That could have described so many things.
I know. That's a good pickup. Yeah, Beanie Babies. There was a time when those were huge in the 90s.
They were.
No,
they were like
these
collectible
things
and
were
everything.
Furbies.
Yes.
That looks like a gremlin from the movie Gremlins.
They kind of do look like gremlins.
Okay.
But they were called Furbies.
Okay.
Furbies.
Well, the Beanie Babies, I just want to say, they were big enough in the 90s that at one time when I went to a meeting in Europe, when I came back, my bags were inspected to make sure I was not smuggling in Beanie Babies.
Really?
Because there was
That's a
such a
problem?
black market for
That did not pay off.
high-value Beanie Babies.
Yeah.
Yeah, some people dropped some serious coin
Yeah.
on some Beanie Babies.
Yeah, and now it's worthless.
they're-
I
Yeah.
think there's a documentary about that,
Yeah.
actually.
Yeah.
About people who invested in
So
Beanie Babies.
Did you decide Furbies
Furbies.
for any
Correct.
particular reason?
Well, we decided together, Eddie and I, that for one, the name is cooler, and two, they're at the current moment sexier in astronomy. So we're gonna.
Are they more energetic?
That I'm not sure.
Okay.
I don't know off the top of my head.
Does anybody
Okay.
know?
Well, there's some new telescope that's going to look for gamma ray bursts,
Oh,
so
okay.
that's why that's in there. It's European Space Mission, actually.
So
Space
try to
telescope.
stump him again in 6 months.
Yeah, when they
See
put
if
that
you have a
thing up,
different answer.
I'll
Yeah.
change my answer.
It'll be
Yep.
Fickle Jim.
Yeah.
Addie, asteroid fragmentation or comet disintegration?
This is a pretty good stumper. I think I'm going to go with comet disintegration.
That's been happening a lot lately. It seems.
It has, yeah. I mean, it always does, but we've been
noticing.
noticing it a lot. There's been a bunch of comets that were like, "Ooh, this one might be exciting," and then it's gone
because it
because it
disintegrated.
disintegrated. But that would have been really
Damn.
cool. Well, we have some data from it, right? So that would have been really cool.
Yeah.
I would assume you would pick the comet also
Um.
because of deep impact.
Well, I like a comet that actually makes it intact all the way into
Okay,
the. you
it
know,
disintegrates when it hits the surface.
I like those. I do like the impacts in asteroid fragmentation.
It's usually
some
due to impact.
It's usually due to impacts, although some asteroids fragment from this spin-up business.
Yeah,
But I like the asteroids smashing into each other. And
It's always good.
blowing
Yeah,
apart that
smashing apart. Yeah.
way. Well, we do have a little bit of space news that's related to comet disintegration. Well, hopefully not, maybe, but it's related to comets. So in addition to space news, we'll talk about parallax from beyond Pluto, Jupiter's fuzzy core, axions, and elves.
yay!
It's not a Lord of the Rings podcast, even though it may sound like that.
R.I.P. Ian Holm.
Oh yeah.
I did not know that.
Bilbo
Yeah.
Baggins and what's his face from Alien?
And from
Yeah.
Time Bandits.
Oh,
That is
I'm
not
sorry.
where he's known.
this
From-
this I know that movie. Well, I'm sorry, I did not know that.
I only very recently put together like
So
I
Ian-
love both Alien and Lord of the Rings, but I did not realize they were the same person until very recently.
Holm.
Ian
Yeah.
Holm. Yeah.
Well,
Because I'm an
rest
idiot.
in-
That-
rest in peace.
Yeah.
yeah.
But before we get to our space news and our science news, featuring, as I said again, Jupiter's fuzzy core, Axion, and elves, this episode of Walkabout the Galaxy is brought to you by Lewis Carroll. "'Twas darketh, and the spryling snipes did gyre and nutate in the wave. So frothy were the tiger stripes, and noctilucent clouds agave. Beware the astroquarks, my son, the slithy whimsy, the lunks who stump. Beware the tricksy Trivy one and keep your eyes on data dump. He took his iPhone in his hand, YouTubing he sought the astro foes, and went Safari to understand the podcast window would not close. His snorfing, gargling interrupted, the astroquarks with talks of space jabbered on, his morn corrupted, oh matter dark without a trace. With gravy waves and paradox, they splither-splather round the hole, 3 babbling mouths, not jabberwocks. The astroquarks did find their goal. 100, 200, the episodes came. Charged dust neutrinos, tau and mu, pulsar glyphing magnetic flame. He grappled with what he thought he knew. And have you joined the astroquarks, those fiendish, chortling, devilish snorks? Oh, fabulistic podcast day, for this I don't even have to pay. 'Twas darketh, and the bursting waves of radio, space-time, and burbling stars, with glee each episode he saves, and dreams of setting foot on Mars.
Very nice.
Lewis Carroll.
Thank you, Lewis Carroll. We appreciate it.
That's a good.
There were some words in there I didn't quite understand.
I liked the word chortling was in there.
Mm-hmm.
There were some other fun ones.
Snorfing,
Snorfing. I feel like I interpreted that.
spriling, snipes.
Yep. Mm-hmm.
Yeah. Mm-hmm. He was maybe a weird guy,
You think?
Lewis Carroll.
Yeah. Good imagination on that one.
Space news.
Space news.
There was this company. Were you at that meeting where Jane Pointer spoke about Worldview?
I've been at a couple of them, I think. Yes.
She gave a keynote at an NSRC, Next Generation Suborbital Researchers Conference, a few years ago, about a company called Worldview that was working to develop a tourist ride to near space.
I worked with Worldview on a proposal to do a payload.
Oh, yeah.
Did not get very far.
It didn't happen. Worldview still exists. They're based, I believe, in New Mexico or Arizona.
New Mexico.
And
Yeah.
they're doing these high-altitude balloons for scientific payloads. And,
And also like military stuff, actually. 'Cause
Okay,
their whole
for,
thing
like-
is they stay in pretty stable orbits. They have this thing called like a racetrack orbit, and they can stay up for like months at a time in like
Right.
this sort of stable orbit. So it's very interesting for like military
And
and
they're-
ground-looking operations.
Yeah, they say orbits, but they're not orbits in the sense that we usually describe because they're not
No.
in free fall around the Earth. They're drifting in the very, very upper reaches of the atmosphere, suspended by buoyancy, not
Right.
by speed, basically. And but Worldview at one point was like they were going to make these like capsules with, I don't know, 6 or 10 people
Yeah.
in there, and you would go up with champagne, and you would be up at like
Like
20 miles.
Dirigible style.
Right, but higher, much
yeah.
higher.
Yeah. But like sort of that
Sort of-
view of things.
Yeah, sort of 3 times higher than you get
Yeah.
on a passenger airplane flight.
High enough that you can see some pretty awesome curvature and like start
The
to get
sky
into.
is getting a little bit dark.
Yeah.
It would definitely be noticeably different than what you see on an airplane, but also it's only about a third as high as the suborbital tourist rocket flights that are being developed. On the other hand, you'd be up there for a couple hours
Yeah.
at altitude. Take a couple hours to go up, hang out up there for a couple hours, have your champagne
Have a
thing
sweet
or
party.
whatever, take a bunch of pictures. No free fall or anything like that, hopefully.
Probably better for a lot of people overall.
Anyway,
Yeah,
Worldview
I could do that.
Worldview has decided they're not going to do tourists anymore, but Jane Pointer, who was one of the people behind that company, and her husband have started a new company called Space Perspective based here in Florida, and they're talking about testing next year and tourist flights in 2022 for a cool 125 grand.
It's cheaper than suborbital stuff right now.
It is cheaper than suborbital. It's,
Yeah.
as we said, not as high, but it is
Longer.
a lot longer.
Yeah.
Right.
Yeah.
Probably
no
a little
free-
safer.
But no free
Only
fall.
30, 40K per hour. No,
Yeah.
no problem.
No problem.
Yeah, in
Is
terms
there
of
like a
price
group-
per minute,
Yeah,
it is
I wonder-
way cheaper.
Is there like a group discount? I don't know.
Buy the whole flight? Probably not.
Yeah, probably not. She and her Jane Pointer and her husband are also well known from Biosphere 2 days.
Right. What was that about?
Biosphere 2?
Yeah.
Oh, it was. So Biosphere 2 was I don't know, have you seen the movie with Pauly Shore?
I have
I'm
not.
just kidding. Um,
I'm learning all sorts of things today.
what? You never saw this movie? It was a ecodome in which they tried to have some humans live in Arizona for some amount of time. That was like a completely enclosed dome, and it was supposed to be its own biosphere. But there were some issues with some of the air filtering, I think, and the
Biosphere
ventilation.
1 being the Earth, basically, and this was to represent a self-contained, to sort of like get ready for living on Mars or something like that.
Yeah, to prep for the movie Silent Running.
Right.
Oh.
Although it did come out, I think they did that after Silent Running.
They did, yeah.
But that sort of idea.
Yes. And it didn't go that well. And there was also some really interesting interpersonal issues, apparently.
Yeah.
And there's some good drama from that. But anyway.
Which is a thing that is probably something you got to pay attention to if you're sending a bunch of people to Mars for 2 years round trip or something like that.
Yeah.
Yeah. I don't, that would be tough.
So there will be maybe balloon launches in addition to our rocket launches soon from Florida.
Locally. Yeah. So what do you think about, would you do, what?
If the price point came down, I would totally
for
100% do that.
$125, I would do it.
I've wanted to go in a dirigible for a while. That there aren't very many of them.
Yeah. These would splash down in either in the Atlantic or in the Gulf of Mexico.
Oh, okay.
Because they're not really propelled. You sort of go up, you know what the weather patterns are. You can steer yourself a little bit by knowing which way the wind is blowing at different altitudes, but you can just basically sort of control how high you are.
Ask our astronomy society. They do like the weather balloon type thing with GPS on it and some sensors and stuff like that. Sometimes it's not very predictable though.
Right, where it's going to come down. Harking back to your stumper, Addie, there's another comet in the news.
Comet Neowise C/2020 F3.
Another one of those guys.
Which means it's right with that name. It means it's new because it's got 2020 in it. That means it was discovered in the year 2020.
And also, it was discovered not by some intrepid human, but by an automated telescope system.
That's why I don't like that naming thing they do with comets, because so many of them now are found by these small handful of survey things that you can't call it Comet Neowise, because there's like 27 million Comet Neowises, right, with letters and numbers at the end.
Yeah.
That's a bummer.
They're called, it's Neowise parentheses C/2020.
Right.
But
yeah, but so it's
so what's special about this one?
It is on its way toward the sun. And it could blossom in a few weeks as it gets closer to the sun, but it could also follow the path of a few others recently and break up.
Right. I have trumpeted, we might be seeing a naked eye comet, a really bright comet, and then they fall apart literally.
But it seems to have a slightly more stable light curve. So the astronomer who wrote about it thinks that it's 70% likely to survive its perihelion, so it's closest to the sun approach. So we'll be able to see it then maybe when it comes back on the other side.
Heading back out is when it would be the best view for us. That's in the July time frame, July 2020.
Yeah, like late June and July. In June 22nd, which is pretty soon, it will be in SOHO, which is a solar observing spacecraft. It'll be in its field of view. So hopefully we'll get some cool images from SOHO.
Right. It'll be so close to the sun that this thing looking at the sun will be able to see it. And that's
really useful a lot of times, because if they do disintegrate, you see it going in and then you don't see anything come out.
And sometimes
they get phenomenal views of it, because they can see just all this, because they can even see with those images like the solar wind,
right?
So they can see the tail waving in the solar wind, and you can see exactly what's happening to it. It's beautiful.
Yeah, and sometimes they actually see the comet in the process of disintegrating in that solar observatory. But let's keep our hopes up for this one to survive its passage by the sun.
Yeah,
I think they were talking about the brightest it would get would be like 2nd or 3rd magnitude, which would be naked eye in the nighttime sky, but not a daytime comet, not one of these sort of comet of the century type
And
bells.
in
it's
July
kind of an average
timeframe.
star or something like that, in the
which
sky.
is in a city you'd still be probably hard pressed to see it. Because it's sort of diffuse, which makes it harder to pick out from the background. But anyway, we'll keep an eye on that and see what happens.
Despite its ununique name, it could still be interesting.
It could be awesome.
Sort of along the same kind of space newsy lines, there was, well, actually, another episode of Walk About the Galaxy means
Another Starlink launch.
another Starlink launch is scheduled for
happened.
Tuesday, I believe now.
Yeah.
So 4 or 5 days from now.
It's
This will
crazy.
bring them up over 500 of these things in orbit, so definitely more than halfway to the point of what they consider their sort of operability. And again, these are SpaceX private venture to offer Wi-Fi via satellite, right?
I think they're also starting to look for beta testers for the network.
Okay. Yeah.
Yeah.
So that'll be interesting to see how that all develops. I think there has been some positive developments in their efforts working with astronomers to minimize the interference of sun glare off these satellites to astronomical observations.
Yeah.
But
There's a new chief of NASA human spaceflight. Her name is Kathy Loiters. She was previously in the Commercial Crew Program, but now she's the chief of human spaceflight at NASA.
How high up
First
is that in NASA?
woman.
So that's like one step below the head of
what-
NASA.
yeah.
no, it's 2
Bas-
steps below.
between her and Bridenstine.
Yeah, there'd be an associate administrator between her and Bridenstine.
Okay.
Yeah, I believe. What did she say her title is? Head of Human Spaceflight?
Which is what,
She's
one of
prob-
like 3 prongs of NASA or something like that, right? Or
There-
2 prongs, or how
There's a
many?
few.
prongs?
There's 3 or 4 associate administrators, and I'm guessing, based on my experience, that she would report to the associate administrator for human exploration and mission operations, or something like that, which is the whole part that deals with anything having to do with people in space. So the space station, human space flight, any human exploration. There's an associate administrator for that. There's an associate
She is
administrator.
associate administrator for spaceflight.
Oh, she is the associate
Yes, yes.
administrator. Then she reports directly
It's
to
just like
Bridenstine.
colloquially, all the articles say like chief of human spaceflight.
This is
Okay.
just too many words, but basically,
Yes.
Bridenstine is the main guy. He's the head of
Yes.
NASA, and then there's like
And he's
2
appointed
or 3
by
or
like,
4
the president.
prongs of NASA, right? There's like
Yes.
the human spaceflight thing,
There's
Science mission director,
Science
science.
stuff.
technology
There's like
mission directorate.
right.
right, and so those are like, so the heads of those are immediately below the head of NASA, and this is the first time a woman has
woman.
been
Yeah,
at
An
this
associate
high-
administrator
of human spaceflight.
of human spaceflight.
Yes.
Okay.
Awesome.
And she's apparently really awesome.
She
Great.
must be if she's got to that point.
Good.
Yep.
New Horizons, not a human spaceflight mission
True.
in terms, although humans did have something to do with it.
As we do with most spaceflight missions.
So it did an interesting, sort of unique new observation.
Oh, I loved
recently.
it. I loved it. This
So
was.
excited.
I was very excited. I put an exclamation point when I mentioned it to my friends. I just
What
thought
does
it was
that
cool.
mean?
I just made it was cool.
How do you put an exclamation point when you mention it to your
Like in a
friends?
text.
That's in when I mentioned it on Facebook.
Oh,
Yeah.
That's where his friends are.
Jim used an exclamation point.
I use that. I rarely do.
Oh, definitely a future stumper is going to be exclamation point or exclamation mark. Everybody's going to say
Oh.
exclamation point.
Oh,
Sneak peek.
You're right. It's probably Mark.
No,
It's point, I think. But
Like,
I'm
definitely had
always
this discussion,
This is a be a good
debate.
stumper for me because I
Oh.
never know it.
Okay. Well.
Okay, we'll do a turntable sometime and have it be a stumper for Josh.
Okay. But the reason I was so excited is parallax.
What is parallax?
You're
Question
always
point.
excited about
I'm excited
parallax.
first of all, the word is cool. But it's just like, the parallax is the way we measure the distance to nearby things, specifically to stars.
I'm parallaxing you right now.
Yeah. Parallax is something that we're all familiar with. If you close one eye and then the other eye, you see the things that are nearby. You shift with respect to the things that are far away from you, right? Do it.
Yep.
Do it right now.
Yeah,
And
my
yeah, I
nose
was doing
goes from
that.
being on the right to being on the left.
Right. If you put your finger out there, it shifts relative to the background. That's parallax.
Whoa.
And we use that same thing. We look at stars when the Earth is on one side of the sun, and then we wait 6 months and look at those same stars, and the ones that are nearby have shifted relative to the ones that are very far away. And because we understand geometry and trigonometry, we can figure out just how far away those stars are. Unfortunately, that
math.
only works for fairly nearby stars because the shifts are tiny. You need great big telescopes to see these shifts
Because they're so freaking far away.
because the stars are preposterously far away. So
I mean,
the
this
amount
was
that they shift-
the idea of parallax was known
way back to the ancient
centuries ago, and it was the absence of an observed parallax
Mm-hmm.
was used as proof that the Earth must not orbit the sun.
That's right.
Yeah.
Yeah,
Because they're
the-
like,
the-
oh, if the Earth is orbiting the sun, how come there's no parallax?
Yeah. No, it's a really intelligent thing that the ancient Greeks did. They asked the question, is the Earth at the center, the sun is the Earth moving? And they went out with a scientific way of testing that, and unfortunately,
They got a null result.
they got a null result,
which was really just a lower limit on how far away things are.
right. But they refused. I mean, it was inconceivable to them that the stars were that far away that they could not show parallax as the Earth moved. So they said that just means there is no parallax and the Earth isn't
Inconceivable.
moving. Seems
It
inconceivable.
does seem inconceivable.
But
it's ridiculous.
We have currently conceived of it. And so the stars are that far away, and we can measure that parallax these days. But an even better way to measure parallax would be, so we're stuck here on Earth. So it's like when you go
Don't
close
rub it
one
in.
eye and then the other eye, you're moving the reason your eye shifts is because you're changing your perspective by a few inches. The reason those stars shift is because we're changing our perspective by a few AU, a few astronomical units. Which
the
is a few hundred-
diameter of the Earth's orbit.
Right, a few 100 million kilometers. But what if we could use a larger baseline than that, right? What if we could look at some stars when we're near Earth and then look at some stars when we're billions of miles away
Near
out past the orbit of Pluto?
Star.
And that's exactly what New Horizons has done, right? It's taken a bunch of pictures of the sky, and we're comparing them to the pictures of the sky that we take here from Earth, and we can see some stars have shifted, and we can measure their parallax and see parallax we couldn't see using
That's
just
20
Earth's orbit.
times bigger than normal,
Right.
than what we typically see.
Awesome.
Right.
Yeah.
So that's a pretty cool use
It's-
of a spacecraft that is out in the middle of just empty space. It doesn't have any other fun things to do.
Yeah.
Yeah.
Do some
It's
parallax
fun.
stuff.
It's fun too because I've asked this kind of question in my astronomy classes before. Like, all right, because we talk about parallax and how you get a bigger baseline, right? You do
Yeah.
Earth 6 months apart or whatever. They're like, how would you do it even bigger? And they're like, go to the orbit of Pluto.
Yeah, that's what
And
we're
we did
We
it.
did it.
Pluto's is 40 AU from the sun,
Ish, something like that, yeah.
Depends on what time of year.
So 40 times the
Pluto
Earth-Sun
year.
distance instead of about 2 AU.
Right.
Yeah.
Right. So that's
That's
tremendous.
cool. I'm surprised that you found it exclamation mark worthy.
Oh,
though.
It's pretty
Yeah,
fun.
yeah.
Also, Brian. So one of the big things with the New Horizons mission is Brian May has been producing all these stereo
of
images
Queen fame.
Of Queen fame. You may have heard of him or the band.
I gather he's doing stay-at-home guitar lessons. Since everybody's quarantining, lots of
He has
people
been
are
in
doing.
the hospital a lot recently. He has
Really?
some significant health issues.
Oh, I
Oh
don't
dear!
know
I'm
about
sorry to
any
hear
of this.
that.
Yeah.
I'm hearing
I mean, I
all
think he's
sorts
okay.
of
He's alive,
terrible
but-
health and news about people today.
Sorry.
Yeah.
The Downer podcast, Josh. But he's done a lot of these images with New Horizons where he does stereo images. So New Horizons takes things at two, and so I think he did that with these two, where he'll produce like a red-blue stereo image that you can then look at with your red-blue
3D
filter.
views.
Yeah.
Nice.
Interesting.
He's done it for like Arakoth and a bunch of the other stuff too.
Okay. Yeah. To transition out of the solar system to the cosmological realm, and
As we
Jim
do.
has been complaining about the solar system / rocket slant
Slash human.
of the trivia questions. So I managed to come up with a somewhat more astrophysical trivia.
Ooh,
question.
it's going to be very
hard.
embarrassing when I get it wrong. too.
It's hard because the astrophysics stuff is so fuzzy.
Oh,
which is
just like Jupiter's
just
core.
like Jupiter's core, which we'll talk about later. But before we talk about axions, I'll just drop the trivia on you. It's
All right.
very straightforward.
Don't
trivia.
hurt him.
Very straightforward trivia with only one part.
What?
Multiple choice. Multiple
Okay.
choice. It's about pulsars. And when the first pulsar was discovered, at first they didn't know what it was. They just saw this regularly flashing signal of electromagnetic radiation, very periodic. And so they gave it a nickname. The discoverers, Jocelyn Bell Burnell and Anthony Hewish. It was discovered in the year 1967. That's important for your choices.
1967.
The question is, what nickname did they give this until then some other pulsars were discovered and they sort of figured out what the heck they were looking at? So I'm going to give you 5 choices. Please do not gasp or splurt or spryling,
Plan on
chortling. No fabulistic exclamations, please. Here are your choices. UHF-1, as a play on the UHF band of emissions in which it was discovered.
It's my favorite band.
LGM, that's your favorite band. LGM1 for Little Green Men 1, since it looked like potentially a regular beacon from aliens. NCC 1701, after the registry number for the Star Trek ship Enterprise, which had premiered the year before. Rosie, after the Jetsons robot, which featured a flashing light. Or Gort, after the robot in The Day the Earth Stood Still, who beams light from his eye slit channel, flashing back and forth like that. So those are your choices for that, and we'll come back to that at the end of the show, as we say. So, Jim,
Axion?
what's an axion? Sounds like something that should have been in our sponsor message.
Oh.
Yeah, axion is a hypothetical fundamental particle that, if real, might be what dark matter is made of.
How many fundamental particles are there that we know about? When
Well,
we talk about fundamental
Kit
particles... Yeah.
Yeah, I mean, there are, I don't remember the number off the top of my head.
Is
but
it
it's,
5, 20, 150?
No, it's on the order of a few dozen.
Order of
Okay.
magnitude, yeah.
Yep.
Okay, there we go.
In the standard model. And, so the standard model has the basic things that matter is made of, like quarks, like we are, and electrons and their relatives, and then the particles that carry forces, like photons, that is a light particle of light, and so forth. But the standard model is known to be incomplete. There are some issues with it, and it's not complete. So we have a bunch of hypothetical fundamental particles which might exist and might solve some of the problems that we have in the standard model of particle physics. And some of those particles, if real, right? I mean, they were made up to solve problems that the particle physicists have. Those
They've
crazy
got
particle
so many problems.
physicists.
They got
I'll
all
tell you,
kind
one
of
of their
problems.
problems is they need to come up with a better name for their model.
The standard model?
Standard model, yeah.
isn't working for me.
Standard.
Agreed. But so they make these particles up to solve their problems, but it turns out that a lot of them, if they're real, might actually solve our problem as well. Our problem, I say, astrophysicists' problem, which is, what the heck is all this dark matter?
The dark
one of our
matter.
problem.
That's one of our problems.
And so axions have been a candidate for, 30 or 40 years now. We've been thinking about axions.
And so what is an axion still? Then?
Well, it would just be it's a very, very light particle, so it has almost no mass, but it does have some, right? Because we have to make up all
What's
the mass.
its etymology?
Axion. Oh,
yeah,
I
why
don't
is
know.
it called an
Axion?
axion? And why did I can just say, a Flibberty gibbet, and it's got almost no mass, and that's a candidate for dark matter. I mean, it's got to come from
Right.
something.
No, it came. Like I said, it came from solving this problem in particle physics called the CP problem, which is this symmetry violation problem. And
Symmetries with an S and violations with a V. So I think you're talking about the
right.
SV.
It's charge
problem.
parity violation is the thing. It's C is for charge, P is for parity, which means switch left and right. And,
P-A-R-O-D-Y?
No.
Oh.
P-A-R-I-T-Y.
It's just the
man.
words podcast now
Yeah.
again.
Yeah.
Sometimes
So,
we devolve into that.
So anyway, so it wasn't just made up. It was made up. It fell out of. So they came up with a theory to explain why this weird thing in the standard model happens. As a result of that theory, a particle fell out of that. They said, if this thing is true, then there must be this particle that exists in the universe that has this very low mass, and they made up the name. The name's like totally arbitrary. Like, it's not based on anything that I'm aware of.
Axion.
I hate it when particles fall out of my
Fall
theories.
out. Like I'm like solving a problem, then I'm like, what's this thing?
I know that's a fan.
Oh, no, it's an
I've always thought that's a fun
axion.
way of saying it, right? You're writing down this. Yeah, it falls out.
I don't know. It just sounds like what I would call a fudge factor. It's like, I can make this thing all work if I just say plus A.
That's right.
Wikipedia.
That's kind of what it is. So
Wikipedia says hypothesized that Wilczek named his new particle Axion after a brand of laundry detergent, and this other person, Stephen Weinberg, called it a Higlet.
Well, this would have been a great trivia for a future episode.
All right, I'll
Now-
come back to it.
But yeah, they went with Axion,
Yes.
and we don't know if it exists or not, of course. But like I said, if it does,
Well, there's something. I mean, we're talking about
we're
it.
talking about it today for a
because-
good reason. We're talking about it because
Of all the
the
wonderful
Axion
things
has been
it
one of the
does.
great possible things that dark matter is. But there's a whole bunch of others. This whole class of things called WIMPs, right? These weakly
Machos.
interacting massive particles and other things. But we can't seem to find any of these things. But very recently, there's a collaboration called the Xenon collaboration.
Watch out for those.
I
I stated.
Hattie said it sounds like
we were looking at this article, and that just sounds like an evil corporation.
Evil corporation, like a
we need to
Bond
get the
villain
agents
type
of
corp-
Bond villain, or from Marvel Comics or something.
we need to get the agents of Shield after the Xenon
Yeah,
collaboration.
the Xenon collaboration.
And like the woman who's in charge of it seems amazing, but one of the pictures in the articles of her, she was in like all purple and very like stern
she's evil.
looking.
She's absolutely
and I
evil.
was,
She's gotta be an evil genius.
Yeah,
they
she's an
always
evil
seem
genius.
amazing.
Yeah.
The evil
Yeah,
geniuses.
the
At
evil
first
genius.
blush, they're always like, "Oh, so brilliant" and everything.
So Xenon is an acronym, but it is named for the element xenon because basically what this collaboration does is this is in Italy, and they're building down deep in a cave. They're building these little cylinders filled with xenon. And the idea being, if they can make very, very pure xenon, and then all around the edges of these things, they put all these photo detectors and so forth, so that when stuff penetrates in the xenon, it causes these little flashes of light. I detect those flashes of light, and that means there's been a collision between something and a xenon atom.
So it's sort of like Cherenkov radiation, which we've talked about other times, where it's like something collides with something and produces light.
Right, that's
So
right.
we have
It's
a
the
lot
same-
of detectors that are like water, a big pool of water.
That's right.
and then
That's
you
right. Neutrino
produce-
detectors work in much the same way.
Yeah.
And xenon is special because it's an inert
It's an inert gas, or not a gas, but an inert
element.
Material.
element. It's actually in the thing. It's mostly liquid, and then it has some gas at the top.
Like me.
And anyway, recently they let out a bunch of their data, and it
Oh, I
seems
thought
like
you were going to say the gas.
they have seen something. That is, so what the idea is, there's going to be some stuff that gets in there from background stuff. That is, there's radioactive stuff in the rocks around, and there's cosmic rays and things like that. But we have we've characterized pretty well how many of those events we should see per any given time. And they've seen an excess number of events. And that excess number of events isn't quite enough to say we've absolutely seen something.
Yeah, as a community, they have this sort of community standard of 1 in 10 million or 1 in a million
1 in
or
3.5
something.
million or something like that.
Yeah.
Yeah, it's this 5 sigma. It's called.
Right.
But they have seen it not to
My
that level.
standards are much lower than that.
Right. So they have seen it to like a 1 in 700 or something like that level. 1 in
I thought
1,000.
it was 1 in 5,000.
Yeah.
Something like
It
that.
was
Okay,
still,
it
like,
could be.
pretty
It was
decent.
still
It's 3.5
it was-
sigma, whatever that means. If
It
you're
was
a math
well
person.
above my threshold.
Right. But here's the
My
thing.
low standards.
So the most likely explanation based on what they have seen is that it is, in fact, axions. Now,
So that means, let me just interrupt you
Yes.
again.
yes.
That means that we know something about an like the prediction of the axions isn't just plus A. We know some
Right,
of the we know enough
right.
of the properties of A to know that what it would do if it hit a xenon atom,
Right.
in
Yeah.
terms of like what kind of flash it would produce or
Right,
something
right.
like that.
How much energy it would release in
Okay.
that collision and that sort of thing. So, I mean, the trouble is, axions are one possible explanation, but there are at least 2 other decent explanations for this.
Yeah.
Yeah. And of course, one of them that's not so decent is it's just random fluctuation, right? That we've
Sure.
ruled
You
that
got
out.
very unlucky.
Yeah, you got very unlucky. But there's also, we possibly haven't characterized the background stuff well enough. There could be contamination, like if you have just a handful of tritium atoms hanging around in that giant vat of xenon.
Yeah.
They produce, they radiate,
similar sort
and they
of
produce a similar
color
signal,
or
and so,
whatever.
It could be that. So this requires significantly more study.
But they seem pretty positive about it.
They seem very positive. Now, I will say this, that I was very excited when I first read this.
Okay. Did you use an
Exclamation mark?
exclamation point?
Exclamation point excited. And then I got kind of half exclamation point excited. I went down a little bit. Because it turns out, even if these are axions, they're not
They're not dark
matter.
Oh.
Because they're axions coming from the sun. They're solar axions, which are axions, hot axions, we call them. They have a lot of...
they are.
Yeah. And dark matter, we know a lot about the general properties of what dark matter should do, and it's not
But-
the same thing that these things
So
would do.
But it would
Would
still
that
prove the
rule-
existence of the particles.
Right. So that's the cool part. Is that
And would
if-
it rule out axions as dark matter? Or
No.
it wouldn't rule them out.
No, it wouldn't
would
rule
just
them out
say we
as
don't,
dark matter. It would just...
and it would say
but-
they exist.
Right, which
So
is a
therefore-
significant step, but it's certainly not the step of we've found what dark matter is, right? So it's not.
Okay.
It's not like they've
Who
detected dark
so,
matter.
So these guys who proposed it when they solved their problem and added the fudge factor, they'll get the Nobel Prize if it's discovered, or will the
Yeah,
people
yeah,
who
I would
discovered
imagine
it
that's
get the
true.
Nobel
I imagine
Prize?
if they do now, what they're doing with this xenon thing is they're now upgrading to a bigger vat and a better vat with better detectors and all that kind of stuff.
More
That's what you
tubes.
do.
That's what you got to do.
That's what you do. And so yeah, if this pans out
That's
over
how we
long
roll.
periods of time and with bigger, better experiments, then yeah, I bet that we'll check. And actually, he may have a Nobel Prize already, but they
Okay.
those guys, yeah. So this is potentially cool. Keep your eyes open.
All right.
Keep your eyes
follow
on
up.
the space.
Yes. So while it's astrophysical, it was also Italian, I guess.
Absolutely.
Right. So we never really quite left Earth. Just because
like
there's
your stamp, John.
these detectors.
It's That's what it says. It's Italian. It's in Italy. But the science these days, like if you look at the Xenon collaboration, there's scientists from everywhere.
I'm sure it's a multinational corporation.
The Xenon collaboration is everywhere.
It's everywhere.
in Terraforming
It's
Mars?
in your
Every-
house. It's
Everywhere
watching
you look, there's somebody from the Xenon
That's right.
collaboration. They
That's
don't
right.
advertise
Somebody
it.
you know. You don't know
Part
it,
of it.
but they're part of the
Yeah.
Xenon collaboration.
Yeah. You know who isn't part of the Xenon collaboration?
Me.
And elves.
You don't know that? They might be.
And because you said you're not part of the Xenon collaboration, I now
I'm
fully
s-
believe that you are
She's-
part of the Xenon
she's
collaboration.
Definitely
There's
part of
no
the
way to
Xenon
know.
collaboration.
All right, tell us about elves, Eddie.
Tell you about elves. Well, this elf detection comes from also some serendipitous observations from some detectors made to see different things. So
Something other than elves. you
something
mean.
other than elves, and we are not talking about Lord of the Rings here, unfortunately. But we are talking about elves, which are atmospheric phenomena. So they're basically like little lightning sprites in the atmosphere. So there's all these little effects in the atmosphere that have some whimsical names. One of the most recent ones is called Steve.
That's whimsical.
Not a
That's
very
weird.
whimsical name. But so Steve was a more recently discovered sort of atmospheric lightning phenomenon. But there's also sprites and elves, and these are all upper atmospheric lightning phenomena that happen when you get sort of cascading events and upper atmospheric energetic particle radiation.
So what-
Totally fascinated by the fact that we know so little about
Our
what's
own
happening in the
atmosphere?
upper atmosphere.
Yeah.
It's hard to observe. So, like, part of the problem with a lot of these features is that you can't see them during the daytime, right? So, like, really intense lightning, we can sometimes see here during the day in Florida. I saw some on the way over here. But, like, most of these effects happen high up in the atmosphere, and you can't see them in the same way we're used to from the ground. But there are a lot of folks who study lightning and different lightning effects.
They're
and-
very transient. I mean, like a lightning flash, like it's
Yeah.
there, it's
Yeah.
gone. It's very localized in space and in time.
Yeah.
And
Having the ISS.
they're sort of too high to easily see from the ground.
Yeah.
And when you're up in orbit, they're way below you, and they've got this big bright thing underneath it, which makes them hard to see.
Yeah,
So
and they're
kinda
not
like-
always associated with huge lightning effects. So sometimes they are more isolated. But so like having the ISS on orbit and having detectors on the ISS has been really beneficial over the last some number of years. There's also other sort of more dedicated like balloon type missions that have gone up and looked for
Right.
these events.
That's the best way to see stuff in the very upper atmosphere, is like to hang out in the upper atmosphere, but it's hard to do that.
So maybe
It's
if you
hard
go
to
with
be-
space perspectives, you'll be
Yeah.
able to see some sprites or elves.
It's hard to be at
Or
the right
Steve's.
altitude, like right. I mean,
Yeah.
you can
Right.
like with balloon, you can get up to a certain height, but then to get higher than that, you got to be a rocket. And if you're rocking, then you're just like zipping through.
Going too fast.
Yeah.
Yeah. Gotta go fast.
So some elves have been observed.
They have, but not from high up this time. From
Okay.
actually here on the ground. So this is from a detector called the Pierre Auger Observatory, which I assume I'm pronouncing that right, but I might
Sounds
not
right.
Be.
Works for me.
This is another collaboration, the Pierre Auger collaboration, where Auger is Auger, by the way.
Okay.
The
That
Augur
is
collaboration,
The
also
Auger.
scary.
Yeah, maybe it's Pierre Auger. I don't know.
If it's Pierre and it's Auger, I think Auger is right.
I thought so too. So this is actually a large detector that was built to study cosmic rays. So it's looking for high energy particles coming down and hitting the Earth.
From elsewhere in the universe.
From elsewhere in the universe. But cosmic rays have very distinct signatures, and more recently they've been seeing these cosmic rays and more shower events that are sort of longer duration and sort of more spread out. And those are indicative of upper atmospheric phenomena where they're sort of showering down. And that's because something happens in the upper atmosphere and it creates this sort of cascade of particles, then this detector can detect.
Like in the upper atmosphere, it's so upper that, like, forget about breathing, right?
Yeah.
It's sort of like space.
It's
If we were there and you open the
bad
window,
news.
you'd feel like space.
Yeah, if you've ever seen...
in the sense you'd be dead instantly.
Yeah, right. The guys who do the high altitude jumps have to wear
Yeah.
spacesuits, basically, right?
Right.
Like technically they're in the atmosphere, but
Right.
you're not.
Yeah. Oh my gosh. Nerd news diversion. We had
He's
previously have I'm exclamation mark excited about this. We mentioned the show on HBO called Avenue 5, which is one of the sort of little humoristic sci-fi shows. Did you watch that?
I watched a couple, one
No.
episode.
Okay. Well, anyway, there was a moment. It wasn't in the last episode, but one of the last couple of episodes that I found. I have to just watch it over and over again. It's so funny.
Does it have to do with elves?
It has to do with opening the window in space.
Oh, don't do that.
It was just so well. I don't know. There was something awesome about it.
All right.
Yeah. Anyway, back on track. So, yeah, there are all these surprising things even nearby, such as the upper atmosphere. Not quite as nearby in Jupiter. We have a spacecraft orbiting. Did I cut you off
No.
on elves? There's a spacecraft called Juno that's been orbiting Jupiter. Its nominal mission ends next year, but its whole goal is to understand the interior of the planet by looking at how Jupiter's gravity tugs on the spacecraft when it gets really close to it. And so they've got a lot of data now accumulated, and there are sort of two main theories about how giant planets form. The core accretion model, which is what we sort of generally teach as the accepted model in intro astronomy, is that the giant planets formed the same way that the planets like the Earth formed, with rocks and things and ice balls running into each other and forming a solid chunk, but they got
Collisions.
big enough that their gravity was able to attract all the gas, not all the gas, but the abundant gas that was in that part of the solar system and become a big gas giant planet. The alternative model is the gravitational instability model, where you get a sort of concentration of the gas and dust or whatever that's in the nebula, and it sort of falls in on itself, and you make something sort of the same way a star is born. And ta-da!
Bradley
So
Cooper.
I'm waiting for somebody to sing there.
Which
wasn't-
version of
wasn't
A
gonna be
Star Is
me.
Born was I going to pick?
Wasn't going to be me. Anyway, so in the
Barbra
former
Streisand.
model, Jupiter would have a core of denser stuff surrounded by a bunch of gas. In the latter model, it would be more uniform in composition. It would be denser in the center because of the weight of everything on top of it, but it wouldn't be so much denser because it's heavier, different stuff. So what they found actually was not really either of those, which is kind of cool.
Wow. Yeah, that is
It
cool.
does have a core, so it does seem to sort of rule out the gravitational instability model, but the core seems to be what they're calling fuzzy.
Okay.
So what does that mean,
What does it
fuzzy?
mean?
Well, there
Like my
isn't
kitty
a
cat?
clear demarcation of the density is going from core value to gas value at a very abrupt
that-
transition.
I feel like it's not that surprising. That there's not an abrupt transition, right? Like we sort of always in the models and in the
But-
drawings in the textbook have like, there's some sort of solid thing that we think is in there somewhere. And
Yeah.
then there's like liquid hydrogen.
Which
and
would be
then
much
there's
less
outside.
dense, right? Yeah. So, but I mean, in those drawings, at least in the intro astronomy books, there's a brown ball.
But we
Yeah,
do-
but we
and
used
do
to
see
draw
that.
electrons
But
as
we
like
see that in
super.
Earth, though. We do see, fairly abrupt boundaries between
There's a metal core,
right between
Sure.
core and
mantle
and so
and
forth.
stuff.
So yeah,
In any event, it's a very fuzzy. I might as well use their word, transition from the sort of core material outward. They're suggesting that perhaps it may have formed in the sort of standard core model that we teach, but then there were some impacts as it was forming that mixed that stuff up. And it's just another one of these go to the impact.
Yeah,
Go to the
yeah.
giant impact.
Giant
Can't explain it. Impact.
Yeah. Why
Always
is
a
Uranus on its
solution.
side? Giant impact. Why does Saturn have rings? Giant impact. Why is Mercury a ball of iron? Giant impact.
Giant impact.
So why does Jupiter have a fuzzy core? Giant impact.
Why
If you-
are Phobos and Deimos around
giant
Mars?
impact? Right.
Or little impacts.
Why does the Earth have a moon? Giant
Giant
impact. So anyway,
It's my new
it
band
has
name.
what they're calling maybe instead of a fuzzy core, this figure is labeling it a dilute core.
That sounds more scientific, but
Not as fun. Not as cute.
not as cute.
Yeah, but it's still, this is sort of a surprising discovery, not, they're sort of like, we'll see this or that, and they saw something else, which is always exciting.
And that's
then
based on like the gravity field or
Yes.
the magnetic field.
the gravity field.
Here's the cool thing about science is, like, this is general. Like, you make a prediction. If you see what you predicted, that's awesome.
Right?
That means you knew something. You understood something about the universe. If you see something different, awesome. You've seen a new thing that nobody's ever seen, but it's cool. And
It's a win-win.
it's a win-win.
Yeah.
Do science.
But for the walkabout trivia, it may not be a win-win.
Oh, it's going to be a
We'll
win-win.
have to see. So we'll start, since this one is specifically tailored for Jim. in the
James, you're up.
astrophysics- No, we're starting
I've
with
done
you.
pretty poorly on some
He's
of the
he's going to bat.
human ones
He's going to
recently.
bat cleanup.
Oh, okay.
So you're first at bat, Addie. Your choices for the nickname given by the discoverers of the first pulsar in 1967 are UHF-1, LGM-1, NCC 1701, Rosie, or Gort.
Rosie.
Yeah, this one I actually do know the answer to. It's LGM1.
It is LGM-1. There you go, Jim.
I thought I had actually heard about that one before. I had actually heard
well,
about
don't
that
tell
one
me
before,
you
but I
don't
liked
tell me
Rosie.
you threw it.
I didn't throw it.
Okay.
I thought it might be Rosie.
Okay.
But I had heard about LGM1 before, but I didn't know it was this thing.
It is Little Green Men
Little Green
1.
Men
Yeah.
1.
Yeah.
Yeah, whimsically. I mean, they
Yeah,
They
that's,
didn't, you
they
know.
got to call it something.
yeah, you got to call it something. And since it's a
Axion.
new type of thing, there's no set naming scheme for this already. So just call
Right.
it whatever the heck you want. And hey, maybe, because that is the kind of signal you might expect from an alien civilization.
It's a beacon.
As a beacon.
And
right?
this first one was 1.3 seconds.
Yeah.
So it's like a sort of nice human kind of time scale.
Right.
It's the kind of time scale that, I mean, for a beacon,
Sure.
for a human beacon, like
Sure.
a lighthouse.
Right.
Beep, beep, beep. It's just, that's what you would put in a science fiction movie if you
That's
were
right.
going after
That's right.
something like that. Yeah. All right. Well, congratulations, Jim.
All right. All right.
You can,
You
For
win
one
this
week, I
one.
can be the king.
you can mention this to your friends with an exclamation mark.
That's right. That's right.
I got the trivia,
I got the
on
trivia.
Walkabout the
Exclamation
Galaxy.
mark. Point. Exclamation point.
While it may have felt like a trip down the rabbit hole, it was just another episode of Walkabout the Galaxy.
The 200th episode.
It was the 200th episode.
Woohoo!
We will be putting out there on our various media platforms some snippets from some older episodes.
8 pi
including
RT.
some cringeworthy,
Oh, no.
probably moments from very early days of Walkabout the Galaxy.
Oh no.
If you liked this episode of Walkabout the Galaxy, make a video of you lip syncing the entire episode and break it up into TikTokable snippets and then get Jerry Seinfeld to like them so they go viral. So then people check out the original, this episode, and it goes viral. Simple.
Is Jerry Seinfeld TikTok?
Jerry Seinfeld got Sarah Cooper viral.
Okay.
Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
At walk_the_galaxy.
and ask us questions anywhere using hashtag Walkabout the Galaxy. Our theme music was composed by Richard Jerusik. Production assistance is provided by Diego Rodriguez. Jillian Gloria is Director of Marketing. Thanks to our listeners in Illinois and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the AstroQuarks signing off until the next episode of Walkabout the Galaxy.
Steve.